Deps.autorun works hand in hand with reactive data sources like session. In this case, the print name function will rerun anytime the name value changes in session. Right now the name is undefined because I just haven't set it yet. So let's go ahead and set it in the browser. And now you see that the print name function reruns again, and my name gets printed to the console. So what we want to do in this episode is take a look at the data structure that gets created when we call deps.autorun. That data structure is called a computation. The computation that gets created is accessible as a parameter to the function, but it's also returned from deps.autorun, so we could assign it to a variable called computation. Over in the browser, if I type computation, we can take a look at the data structure that was created. You can see it's of type deps.computation. We can't create this object manually ourselves. It gets created for us by using deps.autorun. I've expanded the object so we can take a look at some of its properties and methods. The first property to note on a computation is this underscore func property. And the value of that property is the function that we passed as a callback, or as the first parameter to deps.autorun. The second property is an ID, so all computations get an ID. The third is an array of invalidation callbacks. We'll be looking at invalidation in a little bit more detail later. It also stores a parent reference, and so there can be a tree of computations that get formed by nesting functions. And then you can see a bunch of state variables or state properties like recomputing, first run, invalidated, or stopped. And so a computation can be in one or more various states. And the way that it gets into those states is with these various methods in the prototype. So the key methods we'll be looking at are invalidate, onInvalidate, and stop. Let's start off by looking at the invalidate method of a computation. If I call the invalidate method, the computation's function will be rerun on the next flush. You can think of a flush for now as a callback inside of a set timeout. So when I call invalidate, you can see we get dropped inside of the function because it's being rerun, and I can press play and see that the name gets printed again. And let me temporarily disable this breakpoint and show you a few times. And so I can call computation invalidate multiple times, and it will just rerun the function on the next flush. Back in my code, I'm going to create a function called doInvalidation, and that's so that we can set a breakpoint and see what happens to the various computation states. So inside of this function, we'll invalidate the computation. And then we'll print to the log that we're finished calling the invalidate method. And once the code reloads, let's go and set a breakpoint right after we call invalidate. Now I'll call this method, and that'll drop us right into our breakpoint. Okay, up in the over on the right here, I've created a watch expression so we can take a look at the computation object. And if you look down at its state properties, you'll see that we're not recomputing yet, and so recomputing is false. That means rerunning the function here. And the invalidated property is set to true. And this means that we've invalidated the computation, but we haven't rerun the computation's function quite yet. That will happen on the next flush. In other words, after all of this code has finished running. If I press play, I get dropped into the computation's function. And if I look over at the computation's properties, now I can see the recomputing property is set to true. That means we're in the middle of rerunning this function. And the invalidated property is set back to false, because the computation is no longer in an invalid state. It's just rerunning. Back in the code, I can call a method on a computation called onInvalidate, and as a parameter pass a callback function. These callback functions will get called immediately as soon as an invalidation happens on a computation. So to prove this, I can print out to the console invalidate callback, and then we can go back into the JavaScript console and try calling our doInvalidation function. When we call the doInvalidation function, the first line in that function is we call the invalidate method of computation. When we do that, the computation gets marked as invalid, and then all of the onInvalidate callbacks are called. That's why the invalidate callback string is printed to the console first, and then right after that, our finished calling the invalidate method string is printed. And then finally, on the next flush, our computation's function is rerun, and we print the name again to the console. The next method we'll look at is the stop method on a computation. If we call the stop method, the computation won't be run anymore. So if I call invalidate on the computation now, nothing happens. And if we take a look at the computation object over on the right, you can see that it's set to, let's refresh this, and if we do that, we should see that its stopped property is set to true. And so it's in a stopped state. And then if we call invalidate on it, we can call invalidate on it as many times as we want, and it won't matter. Similarly, if we set a new value for name, nothing will happen. So let me refresh the browser. And now the computation isn't stopped anymore. And so if I call session set name and change the name, the function will be called again, and you can see the name gets printed to the console. But again, if I stop it and change the name again, nothing will happen. So stopping a computation can be important when you don't want that function to rerun anymore. For example, in Iron Router, computations from a route are stopped once you navigate to a new route. In summary, in this episode, we looked at the computation data structure that gets created when you call deps.autorun. The computation stores a reference to the function that gets passed to deps.autorun. Anytime we call the invalidate method on the computation, the function that was stored gets rerun on the next flush. We also looked at the onInvalidate method, which lets us pass callbacks that get called each time the computation is invalidated. Finally, we looked at the stop method, which stops the computation from ever rerunning again. All along, we were also looking at state properties, which tell us what state the computation is in. For example, stopped, invalidated, or recomputing.